Hello guys, welcome back to Recursive Path. Today we are going to solve the first problem of LeetCode. We are kickstarting our journey of solving the LeetCode problems. So first problem is to sum. We'll be doing this in sequential manner. So we are not choosing any topic and all that. Like this is like 1, 2, 3, and 4, 5. All these are going to be in sequential manner. That is the first problem to sum. I have also created one repository named as LeetCode. I'll share the link of this repository in the description of this particular video. Please do check it out. Okay, let's get started with this particular solution question. So the question name is to sum. Just a second. Yeah. So let's read it out first. So given an array of integer nums and an integer target, return the indices of two numbers as that they add up to the target. So what it asks is like we have an integer array nums and the target integer, and we need to return the indices of the two numbers. So whose sum are basically equal to target rate. That's what the question is. It also says you may assume that each input would have exactly one solution. So this cannot be any condition where like we don't have any solution, right? And it also says you may not use the same element twice. So we cannot use single element two times, and you can return the answer in any order. So it doesn't matter. We can return the first, second, whatever index is like in any order. Right? So that's the question. Let's go to the examples as well. So this is the nums array that is given to us, that is 2, 7, 11, 15, and the target is 9. So let me just quickly write down the indices as well. So 1, 2, 0, 1, 2, and 3. So these are the indices for these numbers. So if you look at it, like 2 and 7 of these two numbers add up to this particular target, right? So indices of these two are going to be 0 and 1. So that's why the output is 0 and 1. Similarly, if you look at the second example, 2, 3, and 4, indices are 0, 1, and 2. If you look at it, these two numbers, right, 2 and 4 sums to target as 6. So output is going to be 1 and 2. Similarly, 3 and 3, these two are similarly going to be at like the add up to the target 6. That's why the output is 0 and 1, right? So that's what the question is. We do have some of the constraints as well. The length of the array, that is can be from 10 up to 10 to the power 4, and the minimum size is going to be of is 2, because it says we also, as it mentioned, we always have exactly one solution. So that's why the size is going to be 2. Similarly, the size of the number uh, present in the array is basically from minus 10 to the power 9 to 10 to the power 9. And the same as for the target integer as well, from 10 to the power 9 to 10 to the power minus 10 to the power 9 to 10 to the power 9. So I think you hope you got the gist of this particular problem. What it basically says is we have an integer array. It names as nums, and let's create a random array, right, for guys. So let me just create as 2, 3, 5, 23, let's say 37, let's say 70, something like this, right? I can just write the indices as well: 0, 1, 2, 3, 4, 5, something like this. And let me just assume the target as well, that is, let's say 60. So if I said my target is 60, and if you can look carefully in this array, so these two numbers 23 and 37 adds up to my target, that is 60, right? I need to find it, but how do I find it? So the first thinking that comes into my mind is what I can do is I can pick first number, that is, let's say 2, and iterate over the rest of the array, that is 3, 5, 23, 37, 70, and add all the numbers consecutively. Let's say 2 plus 3, 2 plus 5, 2 plus 23, 2 plus 37, and 2 plus 70, right? So it is 5, it is 7, it is 25, it is 39, and it is 72. I can check if any of these numbers is coming to 60. So answer is no, right? So what I can do is I can change my first number to 3 now, and now I can iterate to rest of the array. Similarly, if I do this, then it is going to be 3 plus 5, 3 plus 23, 3 plus 37, 3 plus 70, right? So if you look at it, the addition is going to be 8, 26, 40, 73. But the point is, no sum or no pair is adding up to 60, right? So I can do the similar activity with 5, 23, 37, and 70, right? So as you can see that I have to pick the first number and then I need to iterate over the whole array. Similarly, if it is not found, then I will pick the second number, then the third number, and then the fourth number, and the fifth number, right? So it says like I need to use the loop, right? So let me just do that. I can just write the brute force as well. Let me just write the algorithm as well for brute force. So this is my brute force algorithm. Brute force. So what I will do is I will pick the first element, pick the first number, then iterate over the rest of the number, iterate over the rest of the array, add both the numbers, both the number, that is first number that we have selected and the second number that we are iterating on, and if it is equal to target, then we return the then return the indices, that is I comma j. So I is the index of first number, j is the index of second number. If we don't find it, then go to this first part again and then do the same thing, right? So this first part, since we're doing it every time, and if you haven't found it, then what it does, it says basically, let me just write it down as well, repeat first again. So it says I need to iterate over the first element as well. That means I need to create a for loop for I equals to 0. I is my first element, right? I smaller than equals to, not equals to, sorry, smaller than n I plus plus. What it says is basically my num1, it is named it as num1, is going to be my array of I. So I fixed my num1 right now. Now I need to select the num2 from the rest of the array. That is going to be, j is going to be I plus 1. Why I plus 1? Because I need to iterate over the rest of the array. And also the question says we cannot use the same element twice. So that's why it is I plus 1. And j is again smaller than n and j plus plus. So now I get my num2 as well, that is array of j, right? Now what I need to check, I need to check if my num1 plus num2 is equivalent to target or not. If it is equivalent to target, what I need to do is I need to return the indices, not the numbers again. So I just need to return an array of indices of I comma j. If it is not equivalent to target, then what will happen? It will just rerun it, because then my, let me just show you as well. Then my num1 will change to I equals to 1, right? Because I have a second condition, I equals to 1, then j is going to be 2 now. Then it sum every time num and num2 and check for the target. So that is the what to say, the brute force approach, you can assume. And the time complexity of this approach is going to be O of n square, right? So we have solved this problem with the O(n) square complexity. I think you have got the gist, right? We are picking the first element, then we are looking for the second element. Similarly, we are picking the second element, then we are looking for the third next element, right? So that's how it is. That's how it looks like. Now, since we have solved it in the n square, uh, we are basically not happy with this. then what we can do, we can optimize this approach. How we can optimize? So I think you also know that what is given to us. It has been given that we have given the array that is nums, right? So let me just write it down as the 2, 3, 5, 23, 37, and 70. I'm using the same number, and the target is right. That is 60. Now assume uh, you are in a party or anywhere, right? What you have is basically you have a card. So each uh, member of the party has a card which has a number, right? Let's say 2, 3, 5, 7, 23, 37. These are like persons with a placard, right? Now each placard has a number on written on the card, right? Let's say 2, 3, and all that. Now let's say this particular person which has 23 written, he knows my target is 20. He knows the target is 60, right? So what he's going to do, he's basically going to scan for 37, not for other numbers, right? Because he know that my complement that is going to complete me to 60 is only 37, right? So I need to search for 37 only. So what is this? What it says? It says at any position, if I know my complement is present, then I can always say that my target is achievable, right? So I can explain that once again. So let's say I have 2. So my complement to reach 60 for 2 is going to be 58, right? That is equal to target minus my current number. If target minus current number exists in the array, that means what I say is complement. If it is existing, then we can always say that my target is achievable, right? I think you hope you get the gist, right? Similarly, if for the complement for 3 is going to be 57, similarly for 5 it is going to be 55, similarly for 23 it is going to be 37, and for 37 it is going to be 23, and 70 it is going to be minus 10. So these are my complements. And what I need to take a look is if my complement is present in my array or not. So basically the best way to search an element or like find values present or not in of one time consecutivity, we use map. So now think in this direction, right? So what I'm going to do is I'm going to iterate over my array I equals to 0, I is smaller than n, and I plus plus, right? Oh, assume that I have already created a map of int comma int. So what I'm going to do is I'm going to get my first number, that is num1. It is going to be my array of I, right? Now what is my complement? Let me check for complement as well. Let me create the complement. Complement is going to be target minus array of I, or I can say num as well. Let me do that. Num1, that is my complement. What I need to check? I need to check if my map dot contains, what is check if my map dot contains this particular complement. If it is true, then I just need to return the index of my current, that is I, and map dot get value get val of complement. Okay, I think I haven't told you what we are going to store in the map basically. So map is going to store the value comma index, right? So at which index this particular value is existing. So that's what the map is going to store. So now what we are here doing is basically we are iterating over each the array and figuring out if my complement is present in the map or not. and then we are going to return the value. So let me just give you how it is going to run. So at initially my map is going to be empty, right? Now I came at 2. I check the complement that is going to 58, whether that is present on in map or not. Since it is empty, it is not present, right? I'm going to do, I'm going to insert the value. Okay, I think what we have missed here is insertion in the map. So map dot put array of I, comma I. That's what we need to do. Um, let me just name it as array. It's not a helpful, right? Okay. Now at position 2, since the complement is not present, what I will do is I will add my value to an index 0 in the map. Now going to 3. Now I check for again for my complement whether the value 57 is present in the map. Since it is not present, what I will do, I will add my 3 and the index. Similarly, going to 5, check for my complement whether my 55 is present or not, because the 55 of like 5 complement is 55, right? It is not, then again I will add the value and the index, that is going to be 2. Now similarly I'm going to 23. I will check my complement, that is 37, is it present or not. Since it is not present, what I will do, I will add the current value and the index, that is going to be 3, right? Similarly I'm going to 37. Now the complement to 37 is 23, right? Since 23 is already present, what I will do is I will return the value of this particular index and this particular index and the value of this particular map. So maybe 23, the key for the value for key 23 is 3, right? So what is going to be my array? It is going to be 3, 4. These are my indexes that I need to return. So that's how it will work. Since the lookup for in a map is going to be O of 1, I am iterating over the whole array, that is going to be O of n. So my time complexity for this approach is going to be O of n. And I hope you got the gist of this particular solution, how we solved it and how we have reached to this particular solution, and why did we choose this particular approach as well, right? What are the complements, how we are going to solve, how we solved it, like the brute force approach of n square, the complement approach, and all the things. So yeah, let's go to the coding part now. Okay, now let's start with coding the two-sum solution. Uh, let's start with the brute force one, and then we will go to the optimal one. So in the brute force one, what we have done is we have used a two for loop approach, where the first for loop is for selecting the first value and the second for loop is for the second value, and then just a simple if condition to check if my values are the sum of the values are going to be equivalent to target or not. So that's what we have discussed, right? So I'm just going to create n, that is going to be the length of my array, that is nums dot length, right? Now I need to take two for loops, that is int I equals to 0, I smaller than n, and I plus plus. So this is my first for loop, where I'm going to select my num1, right? That we discussed. So nums of I is going to be my first number. Now I'm going to create the second for loop in j equals to I plus 1. Why I plus 1? Because I cannot use the same element two times, right? So that's why I plus 1. J is smaller than n and j plus plus. And I'm going to select my num2, that is nums of j, right? Now I just need to check whether my nums1 plus nums2 is equals to target or not. If it is equal to target, then we need to return the array, right? So basically new int here I comma j. So this is what we are going to return here. Sorry. Yeah. Now if you're not, then we are going to loop again and the second number will come, right? And need to return the array from here as well, because this is the return type of this is going to be integer, right? So I'm just going to return -1 -1. So this for loop is for selecting the first number. This for loop is for selecting the second number. This is my first number. This is my second number. Checking the condition here, and I'm returning the answer. Returning the answer here. And also for this is just a boilerplate, you can say, or like not the boilerplate, but this is a necessary that we need to return the integer because the return type is integer array. So ideally, we should not reach here because it is guaranteed that we have one solution existing for all the cases, right? So that's a very basic, very simple brute force approach where we have like taken the two numbers, sum it out, and yeah, let's try to run it. If everything works, then ideally this should also work. Okay, I think we have missed the semicolon here. Let's try to run it. You are submitting to. Okay, I think this is what is a LeetCode's value. Okay, now if you look, we have run everything, it works, all the test cases passes and everything. If I click on submit now, what it will work is basically it is going to submit the solution. And if you look here, now all the 63 test cases are passes and the solution is working, right? Now we are going to code for the optimized solution. Now let's code the optimal solution. So I'm just going to remove this and write a new solution for the optimal one that we had discussed for the of the type hash map, right? We are going to use the hash map here. Now let me just create a new variable name n for the length, right? Okay. Now what we have discussed for this solution is basically we are going to create a map to store the store the current values, and we are going to check my complement is present in the map or not, right? So let me just create a map of type integer and integer. Let me just name it as map. I'm going to create a hash map, right? So this is my map to store the values. So let me just write this key as going to be the number, and my value is going to be index. So that's what we are going to store in this particular map. Now I'm going to iterate over the for loop. Iterate over the array, sorry. I equals to 0, I smaller than equals to n, and I plus plus. What I'm going to do here is I'm going to get my current number from the array, that is nums of this is my current number, right? That is my current number, and here we are iterating over the array. Now what we're going to do is basically we are going to find the complement. So as we have discussed, complement is going to be my target minus current number, right? So this is my complement. Complement of the current number. Now what we need to check if my map contains this key or not, right? Because key contains the number. So I'm going to check if my map contains the complement or not. If it is containing the complement, then what I just need to do is I just need to return the array which gives me map dot get my complement comma I, right? Because I'm here, I'm checking if the complement is present in the map. If it is, then we are going to do this. Otherwise, we are going to put this current value in the map. That is going to be my num comma I, right? And here I'm going to just do the same thing, that is returning the array with values as -1 comma -1. Again, this is just uh, the for the code syntaxing and all that thing, because it is returning the integer array. ID the code should not reach to this return, as it is guaranteed that there is always going to be one solution for this problem, right? So that's why we are doing this. To do this solution, we have created the, we get the length, then we get the up. We are iterating over the array. We select the current number, calculate the complement, check if my complement is present in the hash map or not. If it is presenting, then we are going to return the value present in the map for the particular complement and the current index. And if it is not, then we are going to put the current number with the particular index. Here we are returning just because this is the return type of this particular function. Ideally, the code should not reach here, right? So if you have done this everything correct, then if I run it, I think every test case will pass. Okay, we have done something. Acha, okay. We haven't named it correct. So if we do this now, okay, now it runs. And if I click on submit, yeah, now look, it is passing all the test cases, and also this time the time complexity, it is like the runtime is 2 milliseconds and beats 99.16 solutions, right? So I think we have completed this code. Thank you for watching. Thanks for